Okay, so today is Wednesday, April 1st, 2026, April Fool's Day. The time now is 8:40 a.m. in the morning, and I will be starting my grind for Blind 75 today. So today we will work on this question, the lowest common ancestor in the binary search tree. So we will look at a BST. So a BST is different from a binary tree. It has more conditions. So a binary tree has two children. That's why it's called binary. But a binary search tree has all node values are unique. And the second property is that all numbers on the left subtree will be smaller than the root, and all numbers on the right subtree will be bigger than the root. Yeah. And since all are unique, it's a strict direction. Yeah. Okay. Let's read the question. Given a BST where all nodes values are unique and two nodes from the tree PQ return the lowest common ancestor LCA of two nodes. Okay. The lowest common ancestor between two nodes P and Q is the lowest node in the tree T such that P and Q are descendants. So in this case, if I'm given 3 and 8, the answer is 5. Do note that the ancestor is allowed to be a descendant of itself. So in this case, 3 and 4 is actually 3. Okay. So let's look at the topics. Tree, depth first search, binary search tree, binary tree, okay. Aim for a solution that is as good as OH time and OH base, where H is the height of the given tree. Okay. A binary search tree is a tree in which the values of all nodes in the left subtree are less than the nodes value. Okay. All the nodes in the right subtree are greater. Okay. Additionally, every subtree of a BST must also satisfy this property, meaning the less than or greater is valid for all nodes in the tree, not just the root. How can you use this idea to find the LCA of given nodes in the tree? Okay, we can use recursion to traverse the tree. Okay. Can you figure out the conditions we encounter when closing a path between the left and the right subtrees during traversal? Okay. Okay, so I think the first thing that I want to do is to write let candidate ancestor is equals to null. Okay. So at this point, the candidate is null. We'll look at the root. Okay. And then we'll check is we'll let the root equals to the ancestor, and then we will go down the path. Okay, no, we can't let the root be the ancestor. So we'll go down the path. We'll check. Is 3 bigger than 3, both P and Q bigger than the the is both P and Q on the same side? Because if they are, then we need to move. Okay, let's look at this one. So 3 and 4 are both smaller than 5. So the common ancestor cannot be 5 because they'll be on a subtree of 5. They'll be under this family instead. So I'll traverse here. And then 3 and 4, we can find that so if I found P already, I have to find Q. So the candidate is still 3. Then I have to find Q with a depth first search. Okay. Let me think about it. let's see the is it always guaranteed to find one? If nodes P and Q, okay, a split occurs, making the current node the LCA. If yes, this is correct. If both are in the left or right subtree, the LCA lies in that subtree, and we further choose a subtree to traverse. So this is guaranteed to is guaranteed to give a result. Okay. Okay, so root. So we will do uh if P is if P is less than root and Q is more than root, then we will return uh root. Okay. Because they are on both different sides of the tree. So I guess I mean I don't know whether there is an assumption that we always can find, but if not, it's pretty easy, right? So if P is less than root and Q is also less than root, then we'll do return DFS root. Okay. If they are both less than, then we'll do root dot left P Q. Okay. If P greater than root and Q greater than root, then we'll return DFS root dot right P Q. Wait, I'm missing something. Oh, my bad. Just woke up. Okay. So the base case is okay, let's see. There are also other scenarios. So if P is equals to root or Q is equals to the root, then we will else we just return the root. Root dot val root dot val. Okay, so let's try return. I don't think this is right, man. My output is undefined. Oh shit. Hold on. Need to add this. So I need to compare the root val instead, not the root. Okay, that doesn't fix anything. The first case should be 3 and 8. So dot val PQ. Oh, P and Q are nodes. Okay, cool. I am E Q. Okay, hold up. If that changes things a bit. If P dot val is less than root dot val and Q dot val, so P. Oh, they will both exist in the BST. Wow, that's pretty chill. Root dot val is greater than. Okay, so I think one case is like this. The other case should be uh Q dot val is less than root dot val and P dot val is greater than root dot val because they never say that P is smaller than Q. So we gotta account for that. Return root. Am I supposed to output a node? Okay, then if both P dot val less than root dot val and Q dot val also less than root dot val, then we will return DFS root dot left. Maybe just check. I think it will exist, right? So we do P Q. Yeah. Then if both are bigger, then we go right. Turn DFS right Q. Then now is if either one of them is equals, right? Yeah. So now we covered P less than Q more than Q less than P more than. Okay. Then now we do P less than Q less than. Okay. P more than Q more than. So now we have the case of P equals to. Right. So if P dot val is equals to root dot val, then we'll return P. So in this case, you see P dot val is equals to the root dot val. Then we'll return the. Actually, does it even matter? Can I just return root? Oh, I can't. Return P. Else I'll return Q. Yeah. Uh, yeah, let me just. It's equals to this one. Return ancestor dot val. Let's try. Huh? Hold up. Okay, I really need to debug. I must be missing something, right? Uh, this is why I hate it. Why I shouldn't be using the no bracket style. Okay, return root. Okay, so it reaches here. It returns the root. So Unless you tell me I'm supposed to return this. Oh, what? That's not a medium level question. Okay, so the submission data is whatever, man. Because of the, I'm pretty sure this is correct. So we'll take a look at the code. Okay, so all the conditions made it pretty easy, and maybe I shouldn't have read the hints. So yeah, so the whole idea of the BST is that hold on, let me just try again. Much better. Haha. It's whatever. Try again. All right, much better. Okay. So the the problem is that it's a pretty simple question because you need to understand that I think the main point is that if the BST it's a BST, right? Then the answer becomes tougher. I mean easier. Because BST and all numbers are unique. And two notes, the number of test cases that they can give is not that much. So I think this hint pretty much gave us more than whatever we need, right? So if both the values are less than, I mean, if one is less and one is greater, they cannot fall under the same subtree. So the root is guaranteed to be the ancestor. Yeah. So yeah, unless it's like saying like your mom and your dad are not in the same family. Yeah. I mean, they're the same family, then there's something wrong, right? That's why the ancestor is up further up. They don't have the same ancestor. Or rather, their same ancestor is further up. But if let's say they're siblings, right? They're on the same subtree, then we gotta go left and continue looking with the same P and Q. And if we gotta go right, and then at this point, right, I almost return the root, right? Because if P is the ancestor, right, then I will return P. But in the event that if I just write return root, no matter what, it will just return 3, which technically is not wrong. But what if 4 was, I guess. Oh well. If I just return the root, let's try. I write P. If I just wrote return root, does it work? Oh, it works too. Cool. Okay, then we'll just comment this out and then we'll leave it as is. Okay, let's try another question. Okay, let's see. Let's try a DP question. I'm gonna try a DP question. DP. Eeny, meeny, miny, moe, catch a spider on the wall. Okay, word break. Given a string S and a dictionary of strings, word thick. Return true if S can be segmented into a space-separated sequence of dictionary words. So if I'm given S is neat code, word dictionary gives me neat and code. The option output is true. Apple, pen, apple. I get apple, pen, and ape. Apple, pen, and apple. We can reuse words and also not use the words, all the words. So cats in cars. Cats, we don't have cats in cars. Why is this? Wait, hold up. Oh, because we have only car. We don't have that cars. Okay. Holy. Okay. Memoization. I should have picked the other question, man. Ah. Should aim for a solution as good as or better than O n times M times T, where n is the string, length of the string. Okay. S, n is the length of the string S that I'm given. Okay. M is the number of words in the dictionary, and T is the maximum length of any word in the word dictionary. Okay, let's see. Try to think of this okay, it's always about finding the recurrence relation, right? So we iterate through the string S, attempting to pit a word that measures a portion of S, and then recursively continue processing the remaining string. So I guess you just so basically S is made up of like a word from Dick plus S minus word from Dick. And then we just keep going on and on, right? So the base condition is to return true if we reach the end of the string. Yeah, because this will never reach the end of the string. Okay. Each recursive call with index I iterating through as we check all the words in the dictionary and recursively process the remaining string by incrementing I by the length of the matched word. Okay. Yes. Apologies. Okay. So as with every single DP question, I swear I've read this part of the hint like 200 times. You always have an exponential solution just by working off the recurrence relation. So you definitely have to memorize. So we use memorization. We use a hash map to hash the index I, results of recursive calls, and prevent redundant computation. So every time they do this, right, I swear, this is like space complexity shit, right? And every time they say this, right, there's always a way to do it without the extra space. Yeah. It blows my mind, but you know, okay, so let's just do it for let I equals to, we do a const map is equals to new map. And then I equals 0, I less than s dot length, I. So we'll iterate through. So we do const uh word is equals to. So maybe we create a start index. Is equals to uh s dot slice 0 to eh sorry, start to I. Okay. So 0, maybe we start from 1 because the minimum length is 1. Then we'll say if so for cons, so we can do a inner loop, right? Yeah. M is the number of words. For cons, word in word or word dict. Word dict is an array, right? Yeah, word dict is an array. Then we will compare. So if word, okay, never mind. Uh oh, I can't do this because there's two words. We just do candidate. If word equals to candidate, then we will hash map it. Right. So the base condition is to return true. Okay. At each recursive call, we check all words in word dig. So right now I'm trying to do a top-down approach. I'm just brute forcing. Yeah. If any recursive path returns true, we immediately return true. Recursively increment the letter, the length of the match word. Okay, so you see this. So we have cat. So we will do cat. Okay. Then after that, we will save the date. What do I need to hash? Yeah, so I always have the problem to think about what I need to hash. We will set uh so we will probably set the map dot set I true. Yeah. Or maybe we don't do this. We do a new array s dot length dot fill false. Right. This is an array. And then we do map dot I true. So our maybe do s length plus one. Right. Then map 0 is equals to true. So empty string. Return map s dot length. Right. Ah, okay. Because if we can reach end of string, yeah, we can reach end of string. That is correct. Yeah, this will be left. Well, slice doesn't include last element. So we have to let it equal. So less than equal. Yep. Then if word is equals to candidate, then the map I is equals to true. So we will reach here. Okay, it's still missing something. This I know. Then after that, we'll reach here. We'll look at this. So once we find a match, we will at each recursive call, we check all words. All words in word dict. Okay. So there might be different paths to go down. So it's like a depth first search. So let's say for this one, I will do cat, cat, right? So cat, then sin, then after that car, then I reach n. Then there might have been another one like cats, ink. Because I did cat, sin, car. Then after that there might be a cats, okay, in car, rs. Cats in car rs. So that will fulfill the, and my this case won't handle it. So need to handle this case. So once I figure out this case, I think the answer should be there. S is equals to cats in cars. Then the dict is equals to cats, cat, sin, in car, then R, RS. Okay, so I think the iterative method still works. There definitely is a way to do the iterative method. So maybe the iterative method I can start from the end and see if I can reach the beginning. So to reach the end, I need to check from this. Then I'll check here. Then I'll solve the remaining problem. So what's the difference between that and here? So if I do that from the other way around, right? Oh, because I start from here, I might get somewhere, but I may not reach the end. But if I start from the end, try starting from the end, see if can reach front. Yeah, but what if there is like a ARS? So if there's RS, I'll capture it. Ah, yes. See if I can reach the front. Right. So if I do RS, then after that, the next one I'll do in car. Then after that, I will do cats. Yeah. So if let's say I give a new word dict, So we start from N, we do a RS, then we do RS, then we do in car, then we do ATS. Okay. Then we have cats. Oh, but if I can't reach the end, then there can never be a solution. Okay, what if I had the other I have cat, sin, cars? Right. In this case, I'll do RS. I'll do RS. Then after that, I'll do in car. Let's take a look. T maximum length. So right now I'm not using this maximum length or any word. Then I'll do ATS. No, this is really stupid. Because I'm thinking, what if I just do both sides? Start is equals to I. Okay. Then we do a R map. What's the space complexity? And so the R map s dot length is equals to true. So empty string, right? For let I equals to s dot length minus 1, I greater than equals to 0, minus minus I. Then I'll do the same thing. Const candidate goes to 0 equals to s dot length. S dot slice I to n. Then we do this. We do map dot I equals to true, and this equals to I. Okay, then we do R map 0. Wait a minute. Use test case, run. S dot length. So we do R map. S dot length, map S dot length. Oh, sorry, R map. Should be R map. Okay, so far so good. 1, 2, 3. Then we move 1, 2, 3, 4. This is interesting. How does this fail? Both should pass one. 1, 2, 3, 4. Then 1, 2, 3. Should be true one. What's going on? Word. So console.log. This is map. Then this is word. I did it. Let's see. candidate. Okay, one, two, three. Then it matches. Then after that, A. Oh, because it's the same letter, right? So it did three and one, and it says it doesn't match. So I need to consider all cases. So I can't just do left to right. Oh my God. Oof. Okay, it was a good run. It was a good run. It was a good run. Let's go and take a look at the solution. Oh, I hate myself, man. Okay. Nope, I still don't want to use this. Top down. Okay, let's do that. Is there an iterative approach? Okay, let's take a look. Okay, that's what I did. Okay. Oh, so you only need one from the end to the start. Okay, I was so close. For let either W, okay, if I plus W dot length is less than equals to. Oh, I didn't use the. Oh my God, I didn't use the. Oh my God, I didn't use it. I need to build off smaller. Need to build from the end. Oh my God. I can't. Oh my God, I'm so trash. Okay. I'm so trash. Oh man. Build by referencing other indexes. Okay, cool. So we do s dot length minus one. We did this. Greater than or equals to zero. Okay. Word of word. They don't even take out a word, right? So there's no start, no start. Next. Need to consider all cases. Okay. If I plus W dot length word dot length, okay, is less than equal to s dot length. So, and s dot slice I plus word dot length equals to word. Then dp of I is equals to dp of I plus w word dot length. If dp I, and then we just return dp 0. Oh, I got it. I almost got it. Built from the end by referencing other indexes. I keep forgetting this part. So what this is trying to do is if the word If the so you let I is start text, I is start text, check if is valid and within S. Okay. Then check if the word is true, is match. Then after that, you will consider, you will build off where it was. So if before this word it's a match, then we continue with true. Else, okay, so if before this word was a match, it was also a match, then it's true because that's dynamic programming with memorization. Else, it can never be true anyway. This match doesn't matter. Not true to begin with. Oh my days. Oh, DP. Where's DP? Oh, so we need to do map. Maybe I just start spelling it as DP. Then I got a mojo, you know. Oh, oh, it's okay. Great. I mean, I pretty much copied his code, so oh my God, I'm so disappointed. I thought I had it. I really thought I had it. Okay. Anyways, that's it from me. I'll stop here for today. Thank you guys. Bye bye, whoever is watching.